Sustainability and resilience are two words that we hear a lot today in the news, especially in view of climate change and the pandemic. How can AI be exploited to reduce carbon footprints and to ensure resilient flows of goods and services in the face of uncertainty? Hi, my name is Lau Hong Chin. I'm a professor of computer science at the SMU School of Computing and Information Systems. And I'll be teaching this course entitled AI Planning and Decision Making. Now, AI is concerned with designing and building computational systems to perform tasks commonly viewed as requiring intelligence. For a machine to be deemed intelligent, Marvin Minsky, a founding AI professor, once said that it must possess capabilities for reasoning, learning, and planning. So the focus of this course is on automated planning and scheduling for decision-making in business. Planning is a branch in AI that is concerned with the realization of strategies and action sequences, typically for execution by intelligent agents such as autonomous vehicles or robots. And decision-making is concerned with efficient allocation of resources in various business settings and is rooted in operations research. Now, unlike many traditional AI planning courses that spends a lot of time talking about how to move rovers on the moon or how to design robots to move a block from location X to Y. Now, these are fundamental AI problems which are interesting in and of themselves, I must say. But for this course, we take a business-driven approach and spend most of our time discussing real-world resource planning and scheduling problems arising in business enterprises. This can be seen as a second course after you have taken the Intro to AI course and the Algorithms Design and Implementation course. In this course, we will discuss how to design complex models for planning and decision making, and how to design good solution strategies to solve these problems. We kind of go behind the hood to discover the inner workings of planning and scheduling algorithms. And we will discover how to combine machine learning with optimization to generate plans and schedules that hedge against uncertainty. The course is roughly divided into two halves. The first half are the building blocks where we will look at methods and models, such as mathematical programming, constraint satisfaction, basic as well as advanced search algorithms, such as evolutionary algorithms, and a bit of game theory and reinforcement learning techniques. In the second half, which I think is more interesting, we go beyond the static and deterministic settings to tackle planning and decision-making problems under uncertainty. We'll talk a bit about how to deal with dynamic planning and scheduling, how to enable multiple agents, decision makers to arrive at joint decisions, and how to use data to drive decisions for planning and scheduling. We will discuss using real-world applications drawn from a diverse domain in transportation, in logistics, in travel, in military, and in safety and security applications. So what will you learn by the end of the course? Well, in a nutshell, you will acquire skills in AI and OR for thinking about, for understanding, as well as modeling such problems. You will be competent in designing algorithms and implementing them in systems. But beyond that, I think it will be a fun course where we will gather in smaller groups and spend substantial time grappling with problem challenges and solution approaches, and sharing ideas with one another and learning from one another along the way. So why don't you join me in this 10-week journey?